Hello friends. Some time ago, the channel already had a review of the ZimaBoard device, a compact home server designed for self-hosted scenarios, file storage, containers, a media server, and smart home services. In that video, I took a detailed look at the device itself, showed the package contents, installed the system, and launched several services on it. If you missed that review, I recommend watching it. The link is in the description below this video. Today we are continuing this topic with a new model, ZimaBoard 2. This is already a more modern version of the home server platform. Updated hardware, new networking capabilities, and overall a more serious potential for use as a mini NAS, a container platform, or a home services center. In this video, we will get acquainted with the device, take a look at its package contents and design, recall what the standard Zima OS system is like, and then install the Proxmox 9.1 hypervisor on a RAID made of 2 SATA drives, and deploy a Home Assistant OS virtual machine. And before we begin, as usual, I ask you to like this video. It will help other people who are interested in this topic find it, and subscribe to my channel if you have not done so before. The system is built on the basis of a quad-core energy-efficient Intell N150 processor. In my configuration, 16 GB of DDR5-4800 RAM is installed. For the operating system, 64 GB of built-in eMMC memory is provided. On board there are two 2.5 GB LAN ports based on Intel i226V controllers. For connecting drives, there are two 6-bit/S SATA ports, to which you can directly connect hard drives or SSDs. A PCIe expansion connector has also been retained, allowing you to install additional controllers or network cards. And one more nice point, now there are two USB ports here. The previous version had only one, so to install the system you had to use a USB hub in order to connect a keyboard and a bootable flash drive at the same time. In ZimaBoard 2, this issue has already been fixed. Let's start with the way all of this arrives. My kit consists of 2 boxes, the main box with the ZimaBoard 2 itself, as well as a separate box with a stand for hard drives and a display port to HDMI adapter cable. The box with the mini PC is made in such a way that it is impossible to open it without damaging it, which guarantees that you have a version straight from the factory. After opening the box, you can see that everything inside is organized very neatly. Inside there are 2 more boxes. In the larger one is the ZimaBoard 2 itself. It has an orange ribbon, and in the other one there is a power supply with interchangeable plugs for different countries. I will also show the packaging of the ZimaBoard 2 itself separately. The device is located in a dense multi-layer cardboard holder, and the orange ribbon is used simply so that it is convenient to take it out and hold the lid. Under the lid, the ZimaBoard 2 itself is already visible. It lies in an individual mold. Here you can clearly see the thickness of the cardboard. The manufacturer took good care of safety. Besides the ZimaBoard 2, it is made in an aluminum case with massive cooling fins. There was also a small instruction manual in several languages. In the second box, there is a 12-volt, 5-amp power supply. It comes with removable plugs for different countries. There was also a small fan here that can be installed on the case. I will show how this is done later. There is also a dual SATA cable for connecting 2 external drives to the mini PC. And one more small but pleasant part of the package, 2 mini screwdrivers. We will need them as well. In a separate white box, there is a metal stand for installing hard drives. It has a somewhat different design than the one that came with the previous version. It allows you to neatly secure 1 or 2 drives and place them together with the ZimaBoard in a compact assembly. The kit also includes fasteners, cables, and mounting elements for assembling this construction, as well as a riser cable and a frame for PCIe. I have already mentioned the adapter. It is the same as the one that came with the first version and allows you to connect monitors and TVs to the mini PC via HDMI. Now let's take a look at the device itself. The ZimaBoard 2 case is made of aluminum and works as a heatsink. The upper part has massive cooling fins that dissipate heat from the processor and other components. On one side, there are 2 SATA ports for connecting drives, and between them is the power connector, similar to the first version reviewed in the previous video. On one of the long sides, there is a PCIe expansion connector. It allows you to connect additional devices. For example, the manufacturer offers a board for installing 2 SSD drives or something else. And here there are two 2.5 gigabit Ethernet ports, 2 USB 3.0 ports, a mini DisplayPort connector for connecting a monitor, and the device power connector. Out of curiosity, I did disassemble the device after all. I should note right away that the upper part of the case is secured quite rigidly and is actually part of the cooling system. Therefore, I did not completely remove it so as not to damage the thermal interface and not to disturb the heatsink pressure. But the bottom cover is removed quite easily. This is where the included mini screwdrivers that come in the kit were useful. On the reverse side of the board, you can see part of the power components, service controllers, and the CMOS battery, which is responsible for saving BIOS settings. The board layout and the case mounting points are also clearly visible here. Since the device is already disassembled, let's immediately see how to connect the included fan. There is a separate CPU_fan connector on the board, and the fan cable is connected to it. Opposite it, there is a special hole in the case. The fan is mounted on the same screw that holds the case itself. It is long enough for this. In this position, it blows through the heatsink fins and provides additional active cooling if the device is operating under load. Now you can install the stand for the drives. It is attached directly to the case using the same holes and the same screws that are used for the bottom cover of the device. In fact, the mini-PC is placed on the stand and secured with the standard fasteners. After installation, the stand is located under the ZimaBoard case and leaves free access to all connectors on the rear panel: power, USB, network, and video output. Inside the frame itself, the drives are placed, which are then connected to the SATA ports on the board. Now we install the hard drives into the stand. Here I prepared a little better than last time, and now we will conduct an experiment with 2 drives. For mounting, the screws included with the stand are used. They also secure the riser frame for expansion cards. It should be installed on the opposite side from where the PCIe connector is located on the mini-PC. On this side, we also secure the hard drives with screws. Everything is quick and convenient. You do not even need a screwdriver here. The flat cable from the stand kit is connected to the connector on the mini-PC and then routed under the stand to the other side, to the frame. And here we bring it out over the frame, securing it. And here you will already need a screwdriver, using the included screws that at the bottom hold special screw mounts, which also serve as support feet. This is what the result looks like. Now you can install an expansion card here, which will also be attached to the longitudinal part of the frame. Everything is well thought out and convenient. All that remains is to connect the hard drives, the network and power cables, the monitor, and the system is ready to work. To enter the BIOS during boot, you need to press the DEL key. A standard UEFI BIOS from American Megatrends is used, where the main page displays the basic system information: Intell N150 processor, installed memory capacity, and firmware version. In the CPU configuration section, you can see the processor parameters. Power saving settings are also available here, as well as Intel VDX hardware virtualization, which is enabled by default. This is important for running virtual machines and container platforms. The advanced section contains additional system parameters, power management, hardware monitoring, controller settings, and Intel i226V network interface settings. The chipset section contains settings for the platform's low-level controllers, SATA, USB, and other interfaces connected through the chipset. In the boot section, you can set the device boot order. This determines where the system will boot from, for example, from the built-in eMMC or from an external drive. After checking the settings, all that remains is to save the changes through the Save and Exit menu, and the system will continue booting the selected operating system. After exiting the BIOS, the installed system begins to boot. On the screen, you can see the standard Zima OS startup process. Network services, the container environment, and system management components are starting. After the boot process is complete, the system displays the basic information about the device: model, Zima OS version, and the IP address through which you can open the web management interface. Everything here looks exactly the same as in the previous ZimaBlade review. By default, SSH is disabled, and for the first startup you need to set a password for the root user. To do this, press Alt F2 log in as root without a password, and run the standard password command to set the password. In general, the first startup process completely repeats what we already saw in the previous review. Next, we can work with the system's web interface. To do this, you first need to check what address the router assigned to it. After the first login to the web interface, the Zima OS initial setup wizard starts. First, we select the interface language and accept the terms of use of the system. I should note right away that I already showed the operation of Zima OS in more detail in the previous review, so here we will go through only the main points. Next, the system prompts you to create a local user account. You need to specify a username and set a password that will be used to log in to the web management interface. After that, a brief introduction to the capabilities of Zima OS appears. The system shows the main functions, working with drives, file management, remote access, and application installation through the built-in catalog. After completing the wizard, the main Zima OS dashboard opens. A 3-page introduction starts, which explains the Smart Connector application. It can be downloaded to your desktop PC to get direct access to the files in the storage. I also talked about this in the first part. The dashboard itself shows the basic information about the system: processor load, memory usage, drive status, and network activity. In the center are the system applications, file manager, backup, virtual machines, and other services. Before proceeding further, it makes sense to check for system updates. This can be done in the Settings Update section, where the current Zima OS version and available updates are displayed. In my case, the system offered an update to the latest version, 1.5.4. The update is performed directly from the interface and takes only a few minutes. After installing the update, the system reboots, and the current Zima OS version is already displayed in the settings. Next, you can configure working with the drives. To do this, go to the Storage section and launch the Storage Creation Wizard. The wizard offers two options for using the drives. You can use the disks separately or combine them into a RAID array. In our case, we choose Combine Use to create an array of 2 disks. Zima OS supports several disk combination options. For example, RAID 5, RAID 1, or JBOD mode. Since we only have 2 disks, we choose RAID 1, a mirrored array that ensures data safety if one drive fails. Next, we select the disks that will be included in the array. The system shows the detected drives and their capacity. In this case, these are 2 500 GB Western Digital drives. After selecting the disks, you need to confirm the creation of the array. Here the system warns that all data on the selected disks will be deleted. We confirm the operation and start RAID creation. After a few seconds, the array is successfully created. The system shows summary information, RAID type, number of disks, and the total available storage capacity. After the array is created, the RAID synchronization process begins. At this time, the system is already available for work, and synchronization is performed in the background. After synchronization is complete, the storage is fully ready for use. Now the RAID array is displayed in the list of storage devices and is available for working with files. Let me remind you that Zima OS also has a built-in application catalog from which you can install various self-hosted services in just a few clicks. A large number of ready-made containers are available here, from data storage systems to media servers and development tools. For example, you can install Home Assistant, media servers, backup systems, and other popular services directly from the catalog. Useful services for smart home scenarios are also available here. For example, ESP Home for working with devices based on ESP controllers and Homebridge, which allows you to integrate various devices into the Apple HomeKit ecosystem. All of these applications are deployed automatically and do not require manual container configuration. You can also find services for working with Zigbee devices in the catalog, such as Zigbee to MQTT Bridge, which allows you to connect Zigbee sensors and smart home devices through the MQTT bus. In general, the application ecosystem here is quite large, and on the basis of Zima OS, you can build a full-fledged server for home automation. I already showed all of this in more detail in the previous review. And in this video, we will go a bit further and install the Proxmox hypervisor on ZimaBoard 2 in order to use the device as a full-fledged virtualization platform. First, you need to download the system installation image. This can be done on the official Proxmox website in the download section. I will leave the link in the description. I am using the current version at the time of recording, Proxmox VE 9.1, and downloading the installer ISO image. After that, you need to write the image to a bootable flash drive. For this, you can use any image writing utility, for example Balena Etcher. We select the downloaded Proxmox ISO file, specify the USB drive, and start the writing process. When the bootable flash drive is ready, we connect it to the ZimaBoard and enter the BIOS. In the boot section, you need to select the USB drive as the first boot device. After changing the boot order, all that remains is to save the BIOS settings. We select Save Changes and exit, confirm saving, and the system reboots. After restarting, the device will boot from the installation flash drive, and we can proceed directly to the Proxmox installation. After booting from the flash drive, the Proxmox VE installer start screen appears. Here you can choose several startup options, but in the normal case the install Proxmox VE graphical item is sufficient. This is the standard graphical installation. The next step is the license agreement. Everything is standard here. We read the terms and click I agree, after which we can proceed further to the installation settings. At the next stage, you need to select the disk on which the system will be installed. By default, the installer suggests the internal drive. Looking ahead, I will say that Proxmox does not want to install on it. But I have two external drives connected, so I go to the options item. In the settings, you can choose the file system type. Proxmox supports several options: extension 4, XFS, ZFS, and BTRFS, as well as different RAID modes. In this case, we choose BTRFS RAID 1 in order to use a mirrored array of 2 disks. After selecting the RAID mode, a list of available drives opens. By default, the installer may mark several devices, so first we click Deselect All to uncheck all selected disks. Next, I manually select only those drives that will participate in the array. In my case, these are 2 external 500 GB hard drives. After selecting the disks, we confirm the settings with the OK button. Now in the installation window, you can see that the target disk has changed to BTRFS RAID 1. This means that the system will be installed immediately on a mirrored array of 2 disks. After that, you can click Next and proceed to the following installation steps. Next, we specify the regional parameters of the system. We select the country, time zone, and keyboard layout. These settings are needed for correct time display and system operation after installation. The next step is creating administrator credentials. Here you need to set the root user password, which will be used to log into the system and manage the server, and specify an email address. After that, the server network configuration is set up. Here I specified only the host name and left the rest by default. Before the installation begins, a summary of all selected parameters appears. Here you can once again check the settings, file system, selected disks, network parameters, and administrator address. If everything is specified correctly, click Install, and the system installation begins. After that, the installer copies files and configures the system. The process takes a few minutes, after which the server reboots automatically. After booting, the console screen displays the address for connecting to the Proxmox web interface. Now, for further configuration, it is enough to open a browser on any computer on the network and go to the specified address. From this point on, all further work with the server will take place through the Proxmox web interface. When connecting to the server for the first time, the browser may show a security warning. This is normal. Proxmox uses a self-signed certificate, so the browser is simply warning that the certificate authority is unknown. In this case, click Advanced, and then Accept the risk and Continue to open the interface. After that, the login window for the Proxmox web interface appears. Here we enter the root username and the password that was set during installation. After that, we click Login. Let's take a look at the system information. Here the current status of the server is displayed. CPU load, RAM usage, occupied disk space, system information, and kernel version. On the left is the infrastructure tree. This is where virtual machines, containers, and storage are created, and at the top are the main control buttons. But we will not go into the interface in detail right now, because our next task is to deploy Home Assistant OS in a virtual machine. To install Home Assistant OS, We will use a ready-made script from the Proxmox VE Helper Scripts project. You will find the link to it in the description below the video. For this, we copy the command from the script page. Open the shell tab on our server and paste the command to launch the script. After execution, the Home Assistant OS installer starts downloading. During the script launch process, a message appears saying that the PV package could not be installed automatically. This is a helper utility used to display the progress of downloading and unpacking files. Install the package manually with a simple command. apt install PV. Run the script launch command again, after which the Home Assistant virtual machine creation window appears once more. Confirm the action and continue the installation. We return again to the first page. The script offers to create a new Home Assistant OS virtual machine. Confirm the creation, select Yes. Next, the script offers to use the default settings or switch to advanced parameters. I want to change the parameters a bit, so I choose Advanced. Select the Home Assistant OS version. The available options are Stable, Beta, and Dev. The optimal choice is Stable. Next, the virtual machine ID in Proxmox is set. By default, the value 100 is used, and it can be left unchanged. The next parameter is the virtual machine type. Two options are available. Q35, a modern type with PCIe and UEFI support. i440FX, compatibility mode for older systems. We leave Q35. This is the recommended setting. Now you can set the size of the virtual disk. By default, 32 GB is offered, but I will increase it to 64 GB to leave room for future updates and data. The next parameter is the disk cache mode. The available options are None and Write Through. We leave Write Through. This is the default setting. The host name of the virtual machine. I did not change it. I left it as default. Next, the processor model is selected. Two options are available. KVM64, the standard option for compatibility. Host, use of the host processor capabilities. In this case, we leave KVM64. The next parameter is the number of processor cores. By default, 2 cores are used, which is enough for Home Assistant, so we leave it unchanged. Now you can set the amount of RAM. By default, 2 GB is offered, but I will increase the value to 4 GB so that the system can work more comfortably with integrations and add-ons. If you do not plan to run many virtual machines, you can allocate even more. Next, the network bridge is selected. By default, VMBR0 is used, through which the virtual machine will be connected to the network. The script offers to set the MAC address of the network interface. By default, it is generated automatically, so we leave it as is. Next, you can specify a VLAN. If the network does not use VLANs, leave the field empty. The next parameter is the interface MTU. If there are no special settings used in the network, the value can be left empty. The default value will be applied. The script offers to automatically start the virtual machine after creation. We leave Yes so that Home Assistant starts immediately. The last question, confirm the installation. After confirming the settings, the script begins creating the virtual machine. In the terminal, you can see a summary of the selected parameters. Home Assistant OS version, 64 GB disk size, 4 GB RAM, Q35 machine type, and other settings. Then the Home Assistant OS image automatically begins downloading from the official server. After the image is downloaded, the script offers to save it in the Proxmox cache for use in future virtual machines. If you plan to install Home Assistant again, you can select Yes. I leave No so as not to take up extra disk space. Next, the script automatically performs all stages of preparing the virtual machine. Checks and unpacks the downloaded image. Creates a virtual disk. Connects it to the virtual machine. Expands the disk to 64 GB. Creates the VM itself and starts it. After completion, a message appears saying that the installation was successful. Now you can open the console of the virtual machine in Proxmox and watch the first startup process of Home Assistant. At this stage, the system performs the initial initialization. Partitions are created, services are started, and the environment is prepared. This may take several minutes. After booting is complete, Home Assistant shows system information. Here the following is displayed: the IP address of the virtual machine, the Home Assistant OS version, the link to connect to the web interface. Now you can open a browser and go to the specified address, port 8123, to begin setting up Home Assistant. After the first startup, Home Assistant spends some time preparing the system. At this moment, the basic components are installed and internal services are started. Usually this takes several minutes. After the preparation is complete, the initial setup wizard opens. Here you can create a new system or restore it from a backup. I choose to create a smart home from scratch. Next, we create an administrator user. We specify the name, login, and password. This is the account that will be used to log into Home Assistant in the future. The next step is specifying the home location. This can be done later, so I leave it as default. After that, the country is selected. The units of measurement used depend on it, for example, temperature, distance, and time format. Home Assistant also offers to send anonymous statistics to the developers. I usually always enable all options. After the basic setup is complete, Home Assistant automatically scans the network and detects compatible devices. This picture will be individual for everyone. After the wizard is completed, the main Home Assistant interface opens. The overview panel. I also made a review of it not so long ago. The link is in the description. Here rooms, connected devices, and summary system information are displayed. Through this menu, you can connect detected devices. For example, Xiaomi gateways, Zigbee controllers, or other devices found on the local network. In the Settings System section, you can view the system status, component versions, CPU load, and RAM usage. At this point, the basic Home Assistant installation is complete. On my channel, you can find many videos both on configuration and on the implementation of practical use cases. ZimaBoard 2 makes a very good impression as a compact platform for a home server or a smart home system. First, it uses a modern and energy-efficient Intell N150 processor, which provides good performance with low power consumption. For a device that can operate around the clock, this is really an important point. Second, the board has expansion capabilities that are rarely found in such compact devices. For example, a full PCIe slot, where you can install a network card, a storage controller, or other expansions. There are also 2 SATA ports, which makes it possible to connect hard drives or SSDs and use the device as a small NAS or storage server. 2 high-speed LAN ports and 2 USB ports make it possible to use an external keyboard and a boot drive at the same time. The cooling is also worth noting separately. Thanks to the aluminum case with fins, the device can operate in a fully passive mode, without noise and without moving parts. Under high loads, you can also connect the included fan. In my case, I installed it only for demonstration. In practice, it is not needed. And most importantly, all of this works without problems with modern virtualization tools. Proxmox installs without issues, and besides Home Assistant OS, many more useful virtual machines or containers can be deployed on it. That is all. I hope this video was interesting and useful for you. I will be grateful for your likes. They help promote the video on YouTube. If you are not yet subscribed to my channel, now is the perfect time to do it right now. In the description below the video, you will find all the necessary links to stores where you can buy this device, as well as to my social networks, Telegram channels, and a group for discussing smart home topics. Join us, it will be interesting. Thank you for your attention, see you again, and peace to everyone.